I need a good explanation. References are a plus on Python slice notation. To me, this notation needs a bit of picking up. It looks extremely powerful, but I haven't quite got my head around it. It's pretty simple really. There is also the step value, which can be used with any of the above. The key point to remember is that the stop value represents the first value that is not in the selected slice. So, the difference between stop and start is the number of elements selected if step is 1. The default. The other feature is that start or stop may be a negative number, which means it counts from the end of the array instead of the beginning. So, similarly, step may be a negative number. Python is kind to the programmer if there are fewer items than you ask for. For example, if you ask for a:2 and a only contains one element, you get an empty list instead of an error. Sometimes you would prefer the error, so you have to be aware that this may happen. Relation to slice object. The slicing operator is actually being used in the above code with a slice object using the notation, which is only valid within, i.e., is equivalent to. Slice objects also behave slightly differently depending on the number of arguments. Similarly to range, i.e., both slice stop and slice start, stop, step are supported. To skip specifying a given argument, one might use none. So that e.g., a start is equivalent to a slice start. None or a::-1 is equivalent to a slice none. None. -1. While the based notation is very helpful for simple slicing, the explicit use of slice objects simplifies the programmatic generation of slicing. The Python tutorial talks about it. Scroll down a bit until you get to the part about slicing. The ASCII art diagram is helpful too for remembering how slices work. One way to remember how slices work is to think of the indices as pointing between characters, with the left edge of the first character numbered 0. Then the right edge of the last character of a string of n characters has index n, enumerating the possibilities allowed by the grammar. Of course, if high-low %stride equals 0, then the endpoint will be a little lower than high1. If stride is negative, the ordering is changed a bit since we're counting down. Extended slicing with commas and ellipses are mostly used only by special data structures like NumPy. The basic sequences don't support them. The answers above don't discuss slice assignment. To understand slice assignment, it's helpful to add another concept to the ASCII art. One heuristic is, for a slice from 0 to n, think 0 is the beginning. Start at the beginning and take n items in a list. Another heuristic is, for any slice, replace the start by 0. Apply the previous heuristic to get the end of the list. Then count the first number back up to chop items off the beginning. The first rule of slice assignment is that since slicing returns a list, slice assignment requires a list or other iterable. The second rule of slice assignment, which you can also see above, is that whatever portion of the list is returned by slice indexing, that's the same portion that is changed by slice assignment. The third rule of slice assignment is, the assigned list iterable doesn't have to have the same length. The indexed slice is simply sliced out and replaced en masse by whatever is being assigned. The trickiest part to get used to is assignment to empty slices. Using heuristic 1 and 2, it's easy to get your head around indexing an empty slice. And then once you've seen that, slice assignment to the empty slice makes sense too. Note that, since we are not changing the second number of the slice 4, the inserted items always stack right up against the even when we're assigning to the empty slice. So the position for the empty slice assignment is the logical extension of the positions for the non-empty slice assignments. Backing up a little bit, what happens when you keep going with our procession of counting up the slice beginning? With slicing, once you're done, you're done. It doesn't start slicing backwards. In Python you don't get negative strides unless you explicitly ask for them by using a negative number. There are some weird consequences to the once you're done rule. In fact, compared to indexing, Python slicing is bizarrely error-proof. This can come in handy sometimes, but it can also lead to somewhat strange behavior. Depending on your application, that might, or might not, be what you were hoping for there. Below is the text of my original answer. It has been useful to many people, so I didn't want to delete it. This may also clarify the difference between slicing and indexing. Explain Python slice notation. In short, the colons, in subscript notation subscriptable subscriptor make slice notation, which has the optional arguments start, stop, step. Python slicing is a computationally fast way to methodically access parts of your data. In my opinion, to be even an intermediate Python programmer, it's one aspect of the language that it is necessary to be familiar with. Important definitions. To begin with, let's define a few terms. Start. The beginning index of the slice. It will include the element at this index unless it is the same as stop. Defaults to 0. i.e., the first index. If it's negative, it means to start n items from the end. Stop. The ending index of the slice. It does not include the element at this index. Defaults to length of the sequence being sliced. That is, up to and including the end. Step. The amount by which the index increases. Defaults to 1. If it's negative, you're slicing over the iterable in reverse. How indexing works. You can make any of these positive or negative numbers. The meaning of the positive numbers is straightforward. But for negative numbers, just like indexes in Python, you count backwards from the end for the start and stop. And for the step, you simply decrement your index. This example is from the documentation's tutorial, but I've modified it slightly to indicate which item in a sequence each index references. How slicing works. To use slice notation with a sequence that supports it, you must include at least one colon in the square brackets that follow the sequence which actually implement the __getitem___ method of the sequence, according to the Python data model. Slice notation works like this. And recall that there are defaults for start, stop, and step. So to access the defaults, simply leave out the argument. Slice notation to get the last 9 elements from a list or any other sequence that supports it. Like a string would look like this. When I see this, I read the part in the brackets as 9th from the end to the end. Actually, I abbreviate it mentally as -9. On. Explanation. The full notation is, and to substitute the defaults actually when step is negative. Stop's default is lenme_list. 1. So none for stop really just means it goes to whichever end step takes it to. The colon is what tells Python you're giving it a slice and not a regular index. That's why the idiomatic way of making a shallow copy of lists in Python 2 is, and clearing them is with Python 3 gets a list.copy and list.clear method. When step is negative, the defaults for start and stop change. By default, when the step argument is empty or none, it is assigned to +1. But you can pass in a negative integer, and the list or most other standard sliceables will be sliced from the end to the beginning. Thus a negative slice will change the defaults for start and stop. Confirming this in the source. I like to encourage users to read the source as well as the documentation. The Source code for slice objects, and this logic is found here. First we determine if step is negative. Step underscore is underscore negative equals step underscore sign. If so, the lower bound is -1, meaning we slice all the way up to and including the beginning. And the upper bound is the length -1, meaning we start at the end. Note that the semantics of this -1 is different from a -1 that users may pass indexes in Python indicating the last item. If step underscore is underscore negative, lower equals pi long underscore from long 1l. If lower equals null, go to error. Upper equals pi number underscore add a length. Lower. If upper equals null, go to error. Otherwise step is positive. And the lower bound will be 0 and the upper bound which we go up to but not including the length of the sliced list. Else, lower equals underscore pi long underscore 0. Pi underscore increase flower. Upper equals length. Pi underscore increase upper. Then, we may need to apply the defaults for start and stop. The default then for start is calculated as the upper bound when step is negative. If self-start equals pi underscore none. Start equals step underscore is underscore negative. Upper. Lower. Pi underscore increase start. And stop. The lower bound. If self-stop equals pi underscore none. Stop equals step underscore is underscore negative. Lower. Upper. Pi underscore increase stop. Give your slices a descriptive name. You may find it useful to separate forming the slice from passing it to the list underscore getitem underscore method. That's what the square brackets do. Even if you're not new to it. It keeps your code more readable so that others that may have to read your code can more readily understand what you're doing. However, you can't just assign some integers separated by colons to a variable. You need to use the slice object. The second argument, none, is required, so that the first argument is interpreted as the start argument. Otherwise it would be the stop argument. You can then pass the slice object to your sequence. It's interesting that ranges also take slices. Memory considerations. Since slices of Python lists create new objects in memory. Another important function to be aware of is itertools.ilis. Typically you'll want to iterate over a slice. Not just have it created statically in memory. ilis is perfect for this. A caveat. It doesn't support negative arguments to start, stop, or step. So if that's an issue you may need to calculate indices or reverse the iterable in advance. And now, the fact that list slices make a copy is a feature of lists themselves. If you're slicing advanced objects like a pandas data frame, it may return a view on the original, and not a copy. And a couple of things that weren't immediately obvious to me when I first saw the slicing syntax. Easy way to reverse sequences. And if you wanted, for some reason, every second item in the reverse sequence. In Python 2.7. Slicing in Python. Understanding index assignment is very important. When you say ABC, you are saying depending on the sign of C forward or backward. Start at A and end at B excluding element at BTH index. Use the indexing rule above and remember you will only find elements in this range. But this range continues in both directions infinitely. For example, if your choice of A, B, and C allows overlap with the range above as you traverse using rules for A, B, C above, you will either get a list with elements touched during traversal or you will get an empty list. One last thing. If A and B are equal, then also you get an empty list. Found this great table at http://wiki.python.org/moin/moving to Python from other languages. After using it a bit I realize that the simplest description is that it is exactly the same as the arguments in a for loop. Any of them are optional. Then the negative indexing just needs you to add the length of the string to the negative indices to understand it. This works for me anyway. I find it easier to remember how it works. And then I can figure out any specific start/stop/step combination. It's instructive to understand range first. Begin from start. Increment by step. Do not reach stop. Very simple. The thing to remember about negative step is that stop is always the excluded end. Whether it's higher or lower. If you want same slice in opposite order, it's much cleaner to do the reversal separately. E.g. ABCDE1-2::1 slices off one char from left, 2 from right. Then reverses. See also reversed. Sequence slicing is same. Except it first normalizes negative indexes. And it can never go outside the sequence. Toto. The code below had a bug with never go outside the sequence when abs step 1. I think I patched it to be correct. But it's hard to understand. Don't worry about the is none details. Just remember that omitting start and slash or stop always does the right thing to give you the whole sequence. Normalizing negative indexes first allows start and slash or stop to be counted from the end independently. ABCDE1-2 == ABCDE1:3 == BC despite range 1-2 =. The normalization is sometimes thought of as modulo the length. But note it adds the length just once. E.g. ABCDE-53:42 is just the whole string. I use the and index points between elements method of thinking about it myself. But one way of describing it which sometimes helps others get it is this. X is the index of the first element you want. Y is the index of the first element you don't want. I hope this will help you to model the list in Python. Reference: http://wiki.python.org/moin/moving to Python from other languages. Python slicing notation. For start and end, negative values are interpreted as being relative to the end of the sequence. Positive indices for end indicate the position after the last element to be included. Blank values are defaulted as follows: +0-0:1. Using a negative step reverses the interpretation of start and end. The notation extends to NumPy matrices and multidimensional arrays. For example, to slice entire columns you can use slices hold references, not copies, of the array elements. If you want to make a separate copy an array, you can use deep copy. This is how I teach slices to newbies. Understanding the difference between indexing and slicing. WikiPython has this amazing picture which clearly distinguishes indexing and slicing. It is a list with 6 elements in it. To understand slicing better, consider that list as a set of 6 boxes placed together. Each box has an alphabet in it. Indexing is like dealing with the contents of box. You can check contents of any box, but you can't check the contents of multiple boxes at once. You can even replace the contents of the box, but you can't place 2 balls in one box or replace 2 balls at a time. Slicing is like dealing with boxes themselves. You can pick up the first box and place it on another table. To pick up the box, all you need to know is the position of beginning and ending of the box. You can even pick up the first 3 boxes or the last 2 boxes or all boxes between 1 and 4. So, you can pick any set of boxes if you know the beginning and ending. These positions are called start and stop positions. The interesting thing is that you can replace multiple boxes at once. Also you can place multiple boxes wherever you like. Slicing with step. Till now you have picked boxes continuously. But sometimes you need to pick up discretely. For example, you can pick up every second box. You can even pick up every third box from the end. This value is called step size. This represents the gap between your successive pickups. The step size should be positive if you are picking boxes from the beginning to end and vice versa. How Python figures out missing parameters. When slicing, if you leave out any parameter, Python tries to figure it out automatically. If you check the source code of CPython, you will find a function called pslice_getIndexes which figures out indices to a slice for any given parameters. Here is the logical equivalent code in Python. This function takes a Python object and optional parameters for slicing and returns the start, stop, step, and slice length for the requested slice. This is the intelligence that is present behind slices. Since Python has an built-in function called slice, you can pass some parameters and check how smartly it calculates missing parameters. Note: this post was originally written in my blog. The intelligence behind Python slices. You can also use slice assignment to remove one or more elements from a list. This is just for some extra info. Consider the list below. Few other tricks for reversing the list. As a general rule, writing code with a lot of hard-coded index values leads to a readability and maintenance mess. For example, if you come back to the code a year later, you'll look at it and wonder what you were thinking when you wrote it. The solution shown is simply a way of more clearly stating what your code is actually doing. In general, the built-in slice creates a slice object that can be used anywhere a slice is allowed. For example, if you have a slice instance S, you can get more information about it by looking at its s.start, s.stop, and s.step attributes, respectively. For example, A equals slice 10, 50, 2. A.start, 10. A.stop, 50. A.step, 2. 1. Slice notation. To make it simple, remember, slice has only one form. And here is how it works. S. An object that can be sliced. Start. First index to start iteration. End. Last index. Note that end index will not be included in the resulted slice. Step. Pick element every step index. Another important thing. All start end, step can be omitted. And if they are omitted, their default value will be used. 0 lens 1 accordingly. So possible variations are. Note: if start equals end considering only when step 0, Python will return an empty slice. 2. Pitfalls. The above part explains the core features on how slice works. And it will work on most occasions. However, there can be pitfalls you should watch out. And this part explains them. Negative indexes. The very first thing that confuses Python learners is that an index can be negative. Don't panic. A negative index means count backwards. For example, negative step. Making things more confusing is that step can be negative too. A negative step means iterate the array backwards, from the end to start, with the end index included, and the start index excluded from the result. Note: when step is negative, the default value for start is lens while end does not equal to 0. Because s::-1 contains s0. For example, out of range error? Be surprised. Slice does not raise an index error when the index is out of range. If the index is out of range, Python will try its best to set the index to 0 or lens according to the situation. For example, 3. Examples. Let's finish this answer with examples, explaining everything we have discussed. The previous answers don't discuss multidimensional array slicing, which is possible using the famous NumPy. Package. Slicing can also be applied to multidimensional arrays. The 2 before the comma operates on the first dimension and the 0:3:2 after the comma operates on the second dimension. I personally think about it like a for loop. Also, note that negative values for start and end are relative to the end of the list and computed in the example above by given _index plus a dot shape 0. You can run this script and experiment with it. Below is some samples that I got from the script. When using a negative step, notice that the answer is shifted to the right by 1. In my opinion, you will understand and memorize better the Python string slicing notation if you look at it the following way. Read on. Let's work with the following string. For those who don't know, you can create any substring from a z string using the notation a z string xy. Coming from other programming languages, that's when the common sense gets compromised. What are x and y? I had to sit down and run several scenarios in my quest for a memorization technique that will help me remember what x and y are and help me slice strings properly at the first attempt. My conclusion is that x and y should be seen as the boundary indexes that are surrounding the strings that we want to extra. So we should see the expression as a z string index 1. Index 2, or even more clearer as a z string index underscore of underscore first underscore character. Index underscore after underscore the underscore last underscore character. Here is an example visualization of that. So all you have to do is setting index 1 and index 2 to the values that will surround the desired substring. For instance, to get the substring div, you can use a z string 2:8. Because the index on the left side of C is 2 and the one on the right side of H is 8. Remember that we are setting the boundaries. And those boundaries are the positions where you could place some brackets that will be wrapped around the substring like this. A, B, C, D, E, F, G, H, I, J. That trick works all the time and is easy to memorize. My brain seems happy to accept that LST start end contains the start th item. I might even say that it is a natural assumption. But occasionally a doubt creeps in and my brain asks for reassurance that it does not contain the nth element. In these moments I rely on this simple theorem. This pretty property tells me that LST start end does not contain the nth item because it is in LST end. Note that this theorem is true for any n at all. For example, you can check that returns true. Most of the previous answers clears up questions about slice notation. The extended indexing syntax used for slicing is a list start stop step. And basic examples are: more slicing examples. 15 extended slices. I want to add one hello world example that explains the basics of slices for the very beginners. It helped me a lot. Let's have a list with 6 values p, y, t, h, o, n. Now the simplest slices of that list are its sublists. The notation is robot smiley, and the key is to read it like this. Now if you make a slice 2:5 of the list above, this will happen. You made a cut before the element with index 2 and another cut before the element with index 5. So the result will be a slice between those two cuts. A list t, h, o. In Python, the most basic form for slicing is the following, where L is some collection, start is an inclusive index, and end is an exclusive index. When slicing from the start, you can omit the 0 index. And when slicing to the end, you can omit the final index since it is redundant. So do not be verbose. Negative integers are useful when doing offsets relative to the end of a collection. It is possible to provide indices that are out of bounds when slicing, such as: keep in mind that the result of slicing a collection is a whole new collection. In addition, when using slice notation in assignments, the length of the slice assignments do not need to be the same. The values before and after the assigned slice will be kept, and the collection will shrink or grow to contain the new values. If you omit the start and end index, you will make a copy of the collection. If the start and end indexes are omitted when performing an assignment operation, the entire content of the collection will be replaced with a copy of what is referenced. Besides basic slicing, it is also possible to apply the following notation, where L is a collection, start is an inclusive index, end is an exclusive index, and step is a stride that can be used to take every nth item in L. Using step provides a useful trick to reverse a collection in Python. It is also possible to use negative integers for step as the following example. However, using a negative value for step could become very confusing. Moreover, in order to be Pythonic, you should avoid using start, end, and step in a single slice. In case this is required, consider doing this in two assignments, one to slice, and the other to stride. The below is the example of an index of a string. Slicing example. Start end step. Below is the example usage. If you feel negative indices in slicing is confusing, here's a very easy way to think about it. Just replace the negative index with len index. So for example, replace -3 with len list 3. The best way to illustrate what slicing does internally is just show it in code that implements this operation. The basic slicing technique is to define the starting point, the stopping point, and the step size, also known as stride. First, we will create a list of values to use in our slicing. Create two lists to slice. The first is a numeric list from 1 to 9 list A. The second is also a numeric list from 0 to 9 list B. Index the number 3 from A and the number 6 from B. Basic slicing. Extended indexing syntax used for slicing is a list start stop step. The start argument and the step argument both default to none. The only required argument is stop. Did you notice this is similar to how range was used to define lists A and B? This is because the slice object represents the set of indices specified by range start, stop, step. Python 3.4 documentation. As you can see, defining only stop returns one element, since the start defaults to none. This translates into retrieving only one element. It is important to note, the first element is index 0, not index 1. This is why we are using two lists for this exercise. List A's elements are numbered according to the ordinal position. The first element is 1. The second element is 2. Etc. While list B's elements are the numbers that would be used to index them, 0 for the first element, 0. Etc. With extended indexing syntax, we retrieve a range of values. For example, all values are retrieved with a colon. To retrieve a subset of elements, the start and stop positions need to be defined. Given the pattern A list start stop, retrieve the first two elements from list A. I don't think that the Python tutorial diagram cited in various other answers is good, as the suggestion works for positive stride, but does not for a negative stride. This is the diagram. From the diagram, I expect A-4-6-1 to be YP, but it is TI. What always work is to think in characters or slots and use indexing as a half-open interval. Right open if positive stride. Left open if negative stride. This way, I can think of A-4-6-1 as A6-4 in interval.